Hello, today's video will be about a 25 years old multimeter and why old generation or old design multimeters such as the ones we have over 20 years ago are not that good. And what I would like to say is that what you're going to see in this video is not perhaps something that is being reviewed at all, even if there may be somewhere someone on the internet that has documented that. And why I would like to show you this, because in general you have been shown so many digital multimeters on the internet, and the variety available today is so high that we may not consider the pitfalls of digital multimeters, and of course in less than obvious ways. Most of the time they had much greater accuracy than an analog multimeter. However, there are some caveats that are not obvious and they are not specified anywhere in the documentation. And this is particularly so for older and cheaper models, that are some of them still available today. And I would like to show to you why this may have been a disappointment all along the way, and one of the many reasons I have collected so many multimeters and would like to show you, not necessarily today, but along the lines why this is important. Alright, so first of all, let me tell you what were my expectations 25 years ago for purchasing such a multimeter. Well, the first multimeter I had is somewhat similar to this Samoa YX1000A. It was not particularly this model, but a model that was entirely similar to this. And first of all, let me show you what were the common issues I had with this multimeter. Although you're going to see a separate video, a separate review of this particular multimeter. So, the basic idea is that this is a very small multimeter, one that doesn't have enough ranges. And this impacts heavily your capability of using the multimeter properly, because you're not going to see a good accuracy even in the ranges that are available. And I will show to you this with a battery that has been featured in other videos, somewhat as a reference for our multimeters. Alright, so we are on the 10 volts range. Okay, as you see, it's probably on the first scale, the first major indentation, yes, and then a smaller one. So it's almost 1.2 volts, because each division is around 2 volts, if I remember correctly. So 1.2 volts almost, because the next value is going to be for 2 volts. Yes, so it's a bit above 1 volts. Of course, this is not true, because you have seen the same battery being measured with the UNI-T UT-33C, and it gets to around 1.5 volts or 1 point something along the lines. Let me show to you what this meter is capable of, and I'm telling you that this one is very limited. However, it was my first meter, and when I purchased this meter I was expecting much more consistency and much higher accuracy. However, I think 1 or 2 years down the line, it was immediately obvious that this multimeter, despite being digital and despite having a potentially greater accuracy, has some major flaws. However, they are not immediately obvious, and if you look on the documentation, you are not going to find. I mean, the accuracy of this device simply blows off the very small multimeter I had previously, and it gave much more accurate readings. However, there is a pitfall, and I want to show you that. So let me start the multimeter. Still working. The probes, of course, are poor, nothing new. You are already expecting that from very old multimeters. They were not particularly these probes. I think they were ones that looked similar. However, I do not have them. A long time ago they had been damaged beyond repair. Alright, so let's measure the same battery. We are going on the 2000 millivolts range. Alright, I'm going to use the right polarity. And we see 1.8 volts. That it's simply impossible for a 1.5 volts battery. And I'm telling you that this is absolutely impossible. What may happen? Well, let's look on the multimeter and then we will have a clear understanding of what happens. All right, the internal multimeter construction is quite, how should I say it? It's quite simple compared with modern ones. And you can see a lot of discrete components. There are no SMD components, and this was 20 years ago when these multimeters were not built with this technology available. This battery is very old. As you can see over here, it's a battery that has expired around 2010, which shows you that this multimeter has been used probably up to, or was last serviced around 2008-2007, and probably it was used up to the early 2010s at least, which is true. I don't remember exactly when I stopped using it, but clearly it was when I had a much better multimeter available. All right, so the battery we have over here should be possible to measure, and we will see why this meter actually misbehaves and reads a 1.8 volts value. All right, so I will try and make the device make a self-measurement. I doubt this, as far as I could tell, is near impossible. So minus, plus, and let's see. Okay, it cannot be measured, which was quite expected. Let's take another multimeter and make this measurement. So I'm going to take the UT-33C that was featured in so many videos, and let's check the battery voltage. So we are going on the 20 volts range, and let's measure the battery. Okay, as you see over here, the battery measures at about 4.55 volts, which is very low. This is a 9 volt battery, and the voltage has dropped below the 7 or so voltage, the 7 or so volts that in general is considered acceptable. So this battery is clearly below the typical voltage. I will show you something interesting about this multimeter, and this is the aspect I would like to present to you. The fact that surprisingly it has a calibration variable resistor. However, this is not going to be enough, and I'm going to show to you why this is still important. All right, so let's go and try to make a measurement again. And since it's quite difficult to show to you what happens, I will try and make an attempt, but I'm not entirely sure if I will be able to. Okay, let's change the value lower. Okay, we are still on the 2000 millivolts range, which should be perfectly suited for this 1.5 volts battery. And you can see that the value increased to 1.9 volts. So that variable resistor actually changes the calibration for the meter. Let's check now and see what happens. 468. No, it gets over. So 1.92 volts. This is one of the major issues with this type of multimeters. Although I can probably take that value down and calibrate the meter, it's going to be battery voltage dependent. And this is an aspect I have been aware of for a couple of years, but of course it was not immediately obvious. I had this revelation, you would call, when I measured some batteries, and at once my meter said that the battery is low. And then I replaced the battery, and I was surprised to see that the batteries that I previously measured as being good were not anymore. And in case you're wondering, this is not limited to the voltmeter range. It happens also for resistance. And I will show to you exactly one of the resistances that the resistors I have been using. It's a variable resistor. It doesn't matter that because we are measuring the fixed part. I mean that we are measuring the total resistance. So let's see what happens. As far as I could tell, I think the 20 kilo ohms range is fine. Alright, it's registered at 0.45. Let's see. And if I'm going with the calibration resistor further, it's going to register as 0. So I am not making a good enough contact. Yes, it's still fiddly. I will make a definite contact. I think 0.25. So it's clear that the reading is voltage dependent because that calibration resistor actually affects all the readings that are being made by this device. And I will show you exactly the moment I'm trying to have the same calibration as before. So I'm going towards the 2000 millivolts range. I'm measuring it 1.9. Okay, let's see. I cannot place it any lower than that. Let me see if I made a mistake. No, I think that was right. Okay, around 1.9 volts. It doesn't matter. The fact is that you have noticed by now that there is a drift in readings. This is another impact, possibly due to the meter's age, but I'm not entirely sure that it's limited to that. Before we had the readings that were below 2 volts. It may also be due to the fact that the battery has slightly discharged and now shows an even lower voltage than it showed at the beginning of the test. Oh yes, 4.1. So this is what happens. The battery voltage drifts lower and the voltage reading drifts higher. Alright, so this is clearly the case. However, the meter doesn't show the battery as being exhausted, so you would have no indication if something happens. Alright, let's put the same battery into the UT-33C, which is a multimeter that has a design not very different to this meter in particular. And despite it being much newer, it may have the same flaws. So let's see if this is the case. Alright, so I'm taking out the case. It was already unscrewed before, so this is not what should happen. Okay. And let's place the battery and see what happens. Right off the bat, you can see that the low battery indicator is on, which shows that meter readings may not be accurate. However, this doesn't happen in the case of the older multimeter. Let's see how much this impacts our test precision. So the voltmeter is placed again, and let's make the same reading. Okay, so it gets over 2 volts. We can see absolutely the same behavior. Probably this meter draws slightly more current, or the battery is slightly more discharged and it behaves differently, or the calibration resistor inside the device is at a different position, which is more likely because I had already fiddled with the one in this meter for a couple of times, so the value may not be as it was before any calibration. So think about it. You're seeing a value that drifts a lot. It's a 1.5 volts battery that reads as a 2 volts one. And I will show to you exactly how can this be possible. So I'm going to use another meter, and this is going to be an interesting delve in the past, because this particular meter was purchased later than the digital meter you see today, and you may understand this back and forth attempt at finding meters that were having a much better accuracy. So let's take this meter and let me see where are the probes. These are the probes. We are on the 2.5 volts range, and we are looking at a battery that has, let's see, Still 1.5 volts. This is one of the major reasons I have been looking also for analog multimeters, at least when these rudimentary digital models were available on the market. Because analog multimeters, although they have their own flaws, were much more predictable in what they were showing. And think about it, this meter doesn't require any sort of battery, whether we are going on the DC voltage, AC voltage range, or DC current range. And this is entirely true. The only part that requires, the only test that requires internal batteries is the on-meter range. And in this case, of course, you need more batteries and you need to make the constant adjustment in order to make sure that the needle deviates properly and gets to the zero value. And of course, if batteries are lower, you're not going to be able to make this calibration. However, this calibration can be done on the spot, so most of the time you will be able to have reasonably accurate readings even on the ohm-meter range, unless your batteries are truly very much discharged. So this means that an analog multimeter was much more predictable than a digital one, and I shown to you this particular case. So it's clear that we have a 1.5 volts battery. All right, let's move further, because I want to show you clearly that there are other flaws. So you can see, yes, there is no battery inside the multimeter. So this was one of the reasons why I found better analog multimeters to be much more reliable than the first generation I had before. And this was one of the reasons why I couldn't settle for digital multimeters too quickly and consider them to be a good reference. All right, let's get back to this device and let's make another measurement. Let's make a current measurement, because I'm pretty sure that what happens on this device will also happen on this one. And even if I haven't shown to you a current meter reading, this will have a major impact. All right, we have this nickel metal hydride cell that is charged and should provide around 5 amps. I'm not thinking that 5.9 amps is going to be the maximum current being delivered in short circuit, because the battery has been staying for a while and I'm not expecting the meter to pick it accurately. All right, so I'm on the 10 amps range. But first let me show you something else. Let me show you that resistor and see if it offers a good reading, because I'm quite sure that the reading is going to be flowed due to the low battery state. Okay, I need to make a better contact. Yes, I'm not entirely sure why I'm not able to make good enough contact in here so that I can have a stable reading. But I'm quite sure it's not going to be yes, I'm not entirely sure what happens over here. I should have had a stable reading by now, but this doesn't happen. It may be due to the battery. But clearly no good reading is being made, and as you have seen, the value is slightly higher than it should have been. So let me put the test on the ammeter and place the test probe on the 10 amps range. And now let's see what happens when we are attempting to make a reading. Okay, so no reading at all. Oh. So the readings cannot be considered reliable in this battery state. What I was remembering is that when I placed the battery in this device, something else happened, and I will show to you immediately. Alright, so we cannot use reliably such a depleted battery in a meter, but at least this meter shows to us that this is the case. Alright, I'm going to place the original battery in here and see what happens. Okay, I'm going to make a measurement and see. 6 amps, so almost the same as the slightly reduced value I mentioned over here, because it was a value that was stable. So this is the reason why it's not 6, it's 5.9. Alright, so a good reading. Let's make the same attempt at measuring the maximum current on this meter. And for a change, I will place the good battery on this meter, because I wanted to also show to you that even when the meter operates, there is still a difference between older models and newer ones in terms of quality. Alright, so I'm going to make the contact, and I think this is good enough for our test. It's not fully placed, but this wasn't fully placed at all as well. Right, so let's make a reading. We are going on the 10 amps range. Okay. And let's place the probe on the correct connection and let's make the reading. So what we are seeing right now? I'm pretty sure there should have been, yes, okay, so there wasn't a good contact. I'm pretty sure there should have been a decimal point placed somewhere. So let's make the reading again. 1.5 amps, that is very low. I'm pretty sure that fiddling with the variable resistor, the calibration resistor, will make the value much more reasonable, and let's make that attempt. But I'm pretty sure that this is not going to be enough. Let's just make an attempt at seeing if I can make. Okay, I cannot make the readings on this range. I should place it on the other connection. All right. 1.44 volts. All right, so the voltage gets to a somewhat more manageable value. Let's see now. I think that around this point we should be reading 1.5 volts. And think about it. No, 1.44. All right, let's move it even further and let's see what happens. 1.502. This is not far off the reading, but I will show to you that this is not entirely an accurate measurement. However, we have slightly reached a reasonable calibration for the device. Of course, it's not calibration, it's mostly a reference that we are using. But it's clearly that it's closer to the real value we should be seeing. Okay, let's move it on the 10 amps range and make the check again. Okay, so I didn't have a major impact on it. 1.4 amps, and I'm pretty sure that this battery can deliver more than 1.4 amps. However, the meter doesn't have a good accuracy. I'm not entirely sure when was the moment I was aware of the fact that this meter doesn't have a good enough ability of measuring currents, or it doesn't work well as an ammeter. But however, you can see that this is the situation. If you look at specifications, you're going to find out that 1% accuracy is being given by the manufacturer, but this is clearly not the case. And I'm entirely sure that even in other scenarios, these device readings will be far off. So there are major reasons why a 25 years old design is very poor. And you can see that a 20 years old or something along the lines of that works slightly better, but of course it's not perfect. And even though you're going to see this meter being featured on so many videos, you have to take into account that there are some limitations. And in order to show to you what happens and why we have advanced and why you need also a very good multimeter, is that if we are making the attempt of using the same battery, one multimeter in particular, and this is not the only one on the market, I can tell you that, will fare much better and show to you why modern technology really made a change. And of course, not in terms of just accuracy and specifications that are entirely obvious, but also in terms of reliable readings, which of course are not going to be obvious in any of these documentations. All right, so let's place the same battery. So I'm going to take this battery and place the one that is almost depleted in the meter and see what happens. Okay, we placed it inside. Let's turn on the meter. As you can see, the low battery indication is on, so we know what we are facing. And let's see what reading this battery shows. I'm going to use the proper polarity, okay? 1.51 volts. Actually, it's even more accurate than that. And think about it, it's the same value we are going to show even when using the good battery. But let me also show to you how the ammeter value is being read. Okay, I'm expecting along the lines of 5 amps. It's not going to be the same particular value we saw on the UT-43C. 4 amps, but this is quite well because there is a difference between this meter and the other one. Let's change the battery and see how it behaves, but before that, sorry, I remember that we also have to check the ohm meter range. So let's see. And we are taking our resistance and we are making as good a contact as it gets, and we can see 0.45 kilo ohms. So it's a value that is highly consistent. Let's change the battery to the one that has a very good value, and in case you are wondering, we will also see what kind of voltage we have on this battery. Just a moment. I'm changing the battery in the UT-43C, although I could have been using also the other meter, the analog one. Okay, all right, this one shows that as a slightly depleted battery, but for our test is going to be enough. Okay, I think this one fails at around 7 volts or so. Okay, we have a 9 volts battery, and if we are using the analog multimeter, we will see that the voltage gets to around, let's see. Okay, I hope you see the readout. Okay, it gets to around, sorry, didn't place it on the correct range. All right, 9.1 volts. Yeah, so quite a good reading also with the digital one. And let's place it now in this recess connection. Of course, I took off the cover just because we need to move faster and not have any screws that are going to be stopping us. All right, so resistance measurements, 0.4 kilo ohms, 0.454, I think, or something along the line. Okay, making a good contact. 0.45. So it's exactly the same value even if the battery is depleted. This goes on to show what and how a very good multimeter behaves, one that is modern, one that is able to self-calibrate and is truly consistent in its readings. However, you're not going to see those in reviews. And I think this is a major pitfall of most reviews because they cannot cover these particular details that really make a major difference for a hobbyist or for a professional in some circumstances. All right. The next reading I will make is for the battery, and I'm expecting the same 1.51 volts or along the lines. Sorry, millivolts range. 1.51, the same value. Alright, and let's now move on to the current measurement. So we are placing the probe on the 10 amps range, and I'm expecting 4.1 amps or the whereabouts. So 4.2 amps is the same value. Actually, you have to consider the fact that it gets slightly lower the more time you're spending. And I'm not entirely sure I made the same contact before. So 0.41, 0.43, it's, let's say, mostly along the margin of error when making such measurements. However, the measurements are truly consistent. And this goes on to show that this meter and others you may find on the market with the same design are actually many times better than even the classic UT-43C, and I'm not even talking about such old designs like this 25 years old multimeter. So this makes it quite clear that there are many situations where you may suspect that a digital multimeter is not good. And for professionals, those aspects may be true. It may be something that they have kept from telling the others because it's a trade secret. But ultimately, digital multimeters, and particularly the cheap models, have a lot of shortcomings that are not immediately obvious. As mentioned, they may have very good accuracy, and this is of course when the battery is in a predictable state. They offer readings that are much more obvious. However, they are affected by the battery, and this battery voltage drifts is going to manifest itself in ways that are not obvious, but of course are going to affect your perspective on the device. You may even consider it as being degrading, when obviously this is not the case. Another aspect that I would like to show about these old meters, despite having, let's say additional to having low precision, is that the internal build quality is not that great. Of course, this meter features a fuse, which is not a given. This meter doesn't feature a fuse. But overall, I think you are by now quite well aware of what major limitations of such devices were back in the day, and why all digital multimeters that you may even be able to purchase right now, I don't know, for something like 5 euros or dollars, are still a very poor choice. You may start your hobbyist or professional career with such a device, but I recommend against it. In some ways, even if even if analog multimeters are not that great, you will have a good grasp of what happens. Of course, unfortunately, I cannot recommend devices that do not have an internal fuse. So your mileage may vary, which means that you have to be cautious, and of course when you purchase a meter, think very well if you are going to use the features that may damage the device, such as using the current meter readings when you should not place the device in parallel with your load, but in series. So think about that very well. However, an analog multimeter, in some ways, it's much more consistent in readings than these particularly cheap ones. When we are talking about expensive models, expensive digital meters, yes, they are great. When you're starting your career as a hobbyist or as a professional with such a device that has 22,000 counts and has an advanced design that compensates for a lot of issues that may affect calibrations, you are starting with a fantastic device. You will use it many times and you're not going to be disappointed by the purchase. But of course, you have to have a lot more funds available. Such a device, I think, is retailed at around 40 euros or so, and the whereabouts of 45, 47 US dollars. So it's not a cheap device, but one that will certainly be a good start in your career. However, these devices are horrible, and even devices that may be more affordable today and may seem more modern are not entirely the ones that you should be having so much trust upon them. You should not be so much confident in the values that you're going to read. So I hope this video shows you a very good perspective of why back in the day analog multimeters, and particularly cheap analog multimeters, were horrible, very cheap ones. Cheap digital multimeters were not that good. Analog multimeters were a good middle point, and until you find a very good digital multimeter, you will still going to have complaints, particularly if you are very picky about what your meter shows. So I hope this video shows to you a very good picture of why digital and analog multimeters have their pros and cons, and particularly why cheap models are a horrible choice to start your career in electronics, or to develop your passion and have a very good understanding of what you are seeing. So I hope you enjoyed the video, and if you like so, please share the comments, and of course subscribe to the channel, because this is always helpful. So thank you very much for watching.